Okay. Bismillahirrahmanirrahim. So, in the last lecture, we have discussed about various pavement structure type, and we ended up in defining the type of concrete pavement. Today, we'll discuss uh, some more thing about pavements, like uh, what are the composite pavement. In a composite pavement, we have a dense graded hot mix asphalt surface. Then we have an open graded HMA base. We call this an asphaltic base as well. And they are actually, they are surface on already jointed plain concrete pavement. Actually, most of the time, like sometimes in airport pavement, we had this concrete pavement, and for concrete pavement, we do surfacing of an asphalt pavement. So this is what we call a composite pavement. So this type of pavement, they consist of both concrete pavement and asphalt pavement. And then another way is we can have an ordinary uh, what now if you see the difference between the left and the right is that in this sandwich pavement, we had this crushed stone, and then we had jointed plain concrete pavement, and then we have crushed stone, and then there's a dry bound macadam and designated HMS surface. Actually, in a true sense, this is a rehabilitated pavement because we have crushed stone base as well. While in the left one, it's an overlay because you don't have any other layer but an asphalt layer. Now, how can you differentiate between the flexible and rigid pavement? You can do it in three parameters or three ways or three subheadings. One is the load distribution. Now you can see on the left side, there is a layered system in which there is an asphalt concrete. They are overlaid by base and subgrade. This is called, whenever there is an asphalt concrete, we call this is a flexible pavement. And you can see the trapezoidal behavior of the load distribution. The load is, compensated partially by an asphalt layers and then the base layer. While if you look at the right-hand side, this is a rigid pavement. It's a PCC slab, and you can see whole slab is bending. It's just like a beam structure in which you apply the load at the center and there is a deflection at the bottom of the base. So we call this as slab action, and in the slab, uh, it carries most of the load. You must be wondering why there is a differential behavior. You can, think on the left-hand side, this is an asphalt concrete. This is also concrete. The PCC is also concrete. But, the asphalt concrete, asphalt don't have any strength at all. It doesn't carry any compressive strength, or it does not contribute to any strength. Unlike Portland cement concrete, Portland cement has its own compressive strength. So in asphalt concrete, in Portland cement concrete, this cement do two functions. One is to bind the aggregates. And the second is not only it binds the aggregate, but it contributes its own strength. So at the end, a PCC slab can carry more strength. While in asphalt concrete, the asphalt has not got any strength at all. It only acts as a binder. That's why even though it's also a concrete, but some of the load is also carried by the base. You see the presence of base in asphalt concrete means some load taking actions. While in PCC slab, the aggregate base is not required for the strength purpose. Though we need aggregate base, but their function is act as uh, the supporting layer, but not the load taking layer. So this is the first. So there is a trapezoidal behavior in flexible pavement, while there is a beam behavior or the slab behavior in the rigid pavement. So this is one way to differentiate as per the load carries. The other is the initial cost. Obviously, flexible pavement has lower initial cost, but they may not have a lower life cycle cost. What is a life cycle cost? Pavements are designed to fail. Every pavement has its life. In order to, extend its life, pavement, a flexible pavement, if you do a flexible pavement, it will fail earlier and it will, for instance, for 20 years life, at least we have to rehabilitate it, we have to maintain it at least 4 times. While in PCC pavement, normally PCC pavements are designed for 30 years. But even if you take 20 years, most of the time it doesn't need anti-maintenance, maybe a minor maintenance. So this flexible pavement has lower initial cost as compared uh, because it has lower initial cost, but it's a higher maintenance cost. But in the rigid pavement, it has higher initial cost, but it may not require the rehabilitation. So at the end of the analysis, it's the both life cycle cost analysis important together with more initial with the sometimes we don't have enough money to construct these rigid pavement. That's why most of the time we go for the initial cost. And also it's the importance of the road as well. If you are designing a local road in your areas, residential area, even if it is failing, it may not matter. So that's why you say if it is the local road or collector road, you simply go with the flexible pavement. But if it is a major arterial or motorway road, then you have to think, and now we are thinking as well, to at least one lane, the truck lane, as we can say, is to be of rigid pavement. Now, the third parameter is about the durability. Obviously, flexible pavement is less durable than the rigid pavement. Now, what function, why we have additional layer of base and sub-base in both of the pavement? As I have, argued earlier, in the flexible pavement, it provides structural support. It contributes some of the load, while uh, in rigid pavement, all the load is taken by the first or surface layer. Yes, both the presence of base or sub-base layer, they provide drainage in both type of the pavement. So that's why the addition of this base layer in flexible pavement control of the frost section. What is a frost section? In the areas where there is a low temperature or the temperature uh, that cause water to freeze. And once the, the water get freeze underlayer the pavement, what happens is that after, in a sunny weather or after good weather, the ice in the pavement, below the pavement breaks. And whenever it breaks, it will create a thaw effect. It will create an effect that can break the pavement. But how do you, why we don't have this frost section? Is because normally we have an open graded aggregates. The voids in a base is of such extent that they don't allow water enough, uh, they actually allow water enough space to get broken, and uh, the thrust they apply in the open granular layer is much less than the closed granular layer. So since we provide a material of our own choice, open graded aggregate, that's why there is more control of cross section in both of the pavement. Then there is a reduced effect of volume change. That's I've said that since you have a very good open graded aggregates and there is volume change is not very important in case of uh, flexible pavement. One of the phenomena that's why we need is the pumping. What is the pumping? It's, you know, the water that comes out from the pavement. If you don't provide, because in concrete pavement, we provide joints, and this joints is an opening. So what happens if there is a high water table, there will be a, and if you place it just on the subgrade without having uh, base or subbase, whatever you call, this water will, you know, will come out of those joints due to capillary action because the joints are very thin and they provide. So if you don't provide uh, aggregate base, granular aggregate base, and we say a base that has got enough space, that will stop creating that capillary action. You all know that how a thicker tube will react to capillary action to a thinner tube. So that's why it prevents pumping. And at the end, for a cement concrete road, we always need a platform because if you provide a cement concrete right on the subgrade, there will be, I don't know, rusting effect. There will be effect of, something else, moisture effect that will create, that will act on the cement concrete from below. So in order to lay concrete, we always have, you are a civil engineer yourself. You know that each time we have to have a cement concrete, rich mix concrete, we always have a lean concrete base. In flexible pavement, in highway pavement, for rigid pavement, you can have a lean concrete base or you can have an aggregate base as well. So it's not necessary you that ordinary when you do have a lean cement concrete foundation, something like that, you always have a lean concrete. But this lean concrete may not required uh, in a rigid pavement. You can have the aggregate base as well. Construction platform, the volume change. What happens is that, whenever there is a water and don't have compacted a good subgrade, there this will this because if there are fine materials, this subgrade will shrink, right? During the cold weather. So what happens, because there are so many layers and there is a base layer above it, this shrinkage will not travel to the bottom of the base, right? Again, this is what we call, this is a capillary action will be prevented. Now we'll try to look at what are the ways in which the flexible pavement fail, and what are the, you know, what are the reasons, or what are the value of the failure. In flexible pavement, there are three type of cracks that can fail your pavement. One is called the fatigue cracking, means from excessive loading as well as combined with temperature, your pavement fail. Then there is a thermal cracking, in which there is a transverse crack occurs along the road path. This is what we call a thermal cracking. Usually, this thermal cracking occurs around less than of temperature if minus 10 degrees centigrade. Normally, you think, the freezing temperature is below 0 degrees centigrade, but the thermal cracking is survived because uh, the coefficient of linear expansion of asphalt concrete is 10 times less than of an cement concrete. So that's why we don't need a transverse joint. But if you have a consistent pressure below minus 10 degrees centigrade, this thermal crack do occur. In fact, in most of the European countries, you will find this thermal crack very common. It's not damaging the road. It doesn't affect on overall structure uh, capability of a road. Instead, it shows a bad impression. The crack, it's sometimes it can be hairline, but once it get widened, it becomes detrimental for the road as well. Because what happens if the cracks get widened, it will allow water and other material, sand-like materials or any dust material, to penetrate through the pavement. And that is where this problem will cause your pavement to fail. So ordinary, if you look at thermal cracking, it's just a small crack. And if it is, if you do maintenance, it does not require any overlay or something. It's just you have to fill. But if you don't address it, you leave it for the long, then there will be problem because of those cracks. And there is the problem with asphalt concrete is rutting. Its rutting occurs on under the wheel path of a heavy traffic load. If the truck is having more load, that is, it is allowed to be on the pavement, or for which the pavement is designed. Normally, you design pavement on 8-ton standard axle load, or in our countries like Pakistan, we can go up to 12-ton axle load. But if these loads are more than 12 ton, or even those loads that are, more than the required design, what it happens is allow pavement to settle under the wheel path. And what happens is that once this diffraction is created, this bowl is created, then they'll start to have a fatigue crack, and ultimately the road settles down. It get bumpy at some places, it get, risen up other surfaces. This can be of many reasons. We will talk about the reason why it happens and how it can be prevented. But these are the three type of cracks that fails of pavement. So if you ask them what are the three type of the no sense that we have flexible pavement is the fatigue cracking, thermal cracking, and rutting. To the best of my knowledge, these issues in the world are still there. It's not only related to the world, only the developed countries or underdeveloped countries. Even in US, they are still not able to comprehend this fatigue cracking and thermal cracking and fatigue, even though they control loads very well, because it's nothing. Sometimes it has to do with many things. It's not only the loading, but it's this proper selection of the materials and the, what we call the matrix of material. In what proportion the material should be used, in what manner. And I'm sorry to say, as an highway engineer, still that the mix has not been optimized. It works at some places, even in US, the other researcher come up with some other material. It works at other places, but no uniform consensus has been reached, or no uniform, uh, the cure has been till now has been suggested so that you can prevent retting. We'll talk about this detail. Uh, yes, retting. You can sometimes fatigue will cause. This is the first time. Whenever the load is of repeatedly nature, that fatigue, subsequently turned into rutting. That is the first impression. So obviously, when these distresses are there and combination of these three distresses or two distresses will cause the pavement a considerable failure. There are other forms as well. Actually, distress is something that gives you a bad face of anything. It doesn't look like good. When you have distresses, it means your pavement has something wrong with the pavement. So we know rutting, we know alligator cracking. Then there are top-down cracking. There is a bottom-up cracking coming from the bottom, from the base, traveling to the surface, or it can be from surface to the base. There is a thermal cracking, or what we call a low temperature cracking. Then there is a roughness. The roughness is something, in which the surface of uh, the pavement doesn't provide a smooth ride. Again, it's not as, it doesn't show, it doesn't mean that the pavement has structurally failed, but still uh, it's got lots of discomfort. When you talk about any design in transportation, you say our infrastructure should be comfortable to ride. It should be safer. And if there is a roughness, it's not comfortable. Then there is a bleeding. Bleeding is something, coming out, the asphalt binder comes out on the surface. Again, it's not a structural crack. And then there are other cracks as well. We call this ETC. But mind you, uh, most of the time, the rutting, fatigue, and the thermal cracking, they are the major cause of the failure of the pavement. In rigid pavement, we'll have this type of failure in which there is a problem with the joint. The corner of the joint get broken. And there sometimes there is a differential settlement. Normally it is for continuous reinforced concrete pavement. We have discussed it in the last class. And then there is a transverse cracking. Again, this transverse cracking is similar to what we have the inflexible pavement, but concrete has a pronounced transverse cracking because it has more coefficient of linear expansion or contraction as compared to this. So it reacts to this temperature change much. That's why we have a jointed concrete. And what by providing joint, we want to channelize those transverse cracks. But sometimes, it always not the place where you find the cracks. Actually, when we provide joint, we want that those cracks should be within that joint. But sometimes those cracks, comes out of that joint. Maybe because of the low, unexpected coefficient of linear expansion, or sometimes maybe the joint length may be too long for this type of pavement. Sometimes the base also has a problem. So we may have a transverse cracking. It's very common. So if you want to define what are the stresses, there is a cracking, there is a faulting. Faulting means a load failure. There is the pumping. Pumping, as I've said, water pumps out of the joints. There is a blow up. Concrete, sometimes get get a graveyard structure like that. It comes out from some place. Again, because of the bottom problem, the pumping and the sometimes the frost section. There is scaling. Scaling is just like bleeding in asphalt concrete, in which the skin of PCC comes out, just like bleeding. So you won't find a fair face concrete. There is spalling, some joint get broken from some places. It is different from, the corner of faulting, because that cracking is sometimes at the corner, but the faulting or spalling can be anywhere within the joints. Blow up. It means the pavement, get a heave-like structure. It blow up like this, like this. This like punch out something. So what about the pavement design methodologies? The pavement design methodologies, uh, you can design a pavement according as per your experience as well. You can do empirical method. Uh, you have found some parameters. Uh, you have tested some road. And then you do mechanistic empirical stresses, in which you calculate stresses, strain on already calculated road. You already have designed the pavement, and you uh, test that pavement for stress and strain. So we see this is the mechanistic form that is. And now we have only mechanistic, in which we use solely this pavement stresses, strain, and see what are their limits. So we stop here and then we'll continue after the break.